Now, as the name suggests, we are now studying about calorimeter, which is a device which is used to detect or calculate what? Heat. See, we have already devised a formulation for the heat absorbed or heat lost by the body. In each case, the heat is going to be calculated by same formula, mc delta T. Now, the device which does so is called calorimeter. So, calorimeter is a simple device. See what it consists of. First of all, it consists of a copper vessel. This is a copper vessel, okay. Now, copper vessel, this whole thing, because we have to prevent leakage of heat from system to surrounding, so we insulate this whole thing by wooden jacket. So, consider that this is a wooden jacket, okay, so as to prevent heat by conduction, okay, first of all. Second prevention of heat is done by filling this gap, this whole gap between copper vessel to the wooden block by some woolen material, cotton, which has a lot of air sacs, air packets, okay, because we know that air is a bad conductor of heat. So this thing is filled by anything like husk or cotton dust, something like that. So this is also a prevention of heat by conduction. Now this thing is, this whole apparatus is covered by wooden lid to prevent heat loss by convection, because convection current are going to carry the heat from this container to surrounding. So to prevent heat loss from convection current also, we insulate it. Okay, now this copper vessels outside and insides are both polished, they are made shiny. Why? To prevent heat loss by radiation. So all conduction, convection and radiation are taken care of now, okay. So this calorimeter works on a very simple fact, which is also called law, I won't write it here, I'll write it here, that is called law of mixtures. So what do you think, what law of mixtures would be? The law of mixture states that heat loss is equal to heat gained. That means heat loss by one body is equal to heat gained by another body. So suppose this thing is at higher temperature, this mark is at lower temperature, and I mix them up. So obviously heat is going to flow from a region of higher temperature to region of lower temperature. So this higher temperature thing is going to lose heat, whereas the lower temperature thing is going to gain heat. So heat loss by one body is equal to heat gain by another body. How it is done? This thing is provided with a stirrer. This stirrer is used to perfectly mix all the components or this container is using. For example, there is a material A and material B, or suppose there is a liquid A and liquid B. So to mix the mixtures which is present in the copper container, to mix them perfectly, the stirrer is used. And another gap is there which is used for thermometer. So thermometer measures the change in temperature, because suppose the heat is flowing from one to another, there will be consequently a point where a common temperature is attained. So that common temperature will be noted down by the thermometer. So to understand it more well, consider we have a substance A of mass M1 at temperature T1, okay. Now we have another substance B which is of mass M2 and temperature T2. Considering that T1 is greater than T2, that means this is the heated body, this is the colder body, and the heat is going to transfer from body at higher temperature to body at lower temperature. So heat gained will be by this and heat lost will be by this. So after mixing these A and B, let us say the common final temperature reached or attained is T. So what would be the formula applicable for, first of all, this body A? The formula is mc delta T, right? So M for A is mass is M1, C1 be the specific heat capacity of this body, so I have to mention C1 as well, and here C2 as well, okay. While delta T would be the final attained temperature is T, and T is going to be less than T1 because T2 has increased from T2 to T, whereas T1 has decreased from T1 to T. So common temperature being T, so delta T here would be what? T1 minus T. Now in other case, again Q is equal to MC delta T. For B body, the mass is M2, specific heat capacity C2, whereas the change in temperature for this would be gain in temperature, which is T minus T2. T minus T2. And now since we took all the precautions to prevent heat loss from the container by process of conduction, convection and radiation, so which is actually practically not possible, but if theoretically if it is happening, so we are considering the theoretical fact that even if it is happening, then the heat loss by one body will be equal to heat gain by another, which means this is equal to this. This is laws of mixture, and this is called the theory of calorimetry.